6.2 Operations involving functions. Learning intention. To evaluate and combine functions, including composite functions. Success criteria. I can evaluate a function for a given value. I can substitute algebraic expressions into a function correctly. I can find composite functions such as f after g of x and g after f of x. I can simplify composite functions fully. I can solve equations involving composite functions. I can find unknown constants when given function values. Notation. We have already seen that a function may be written in any of these ways. F of x equals 3x minus 2, fx maps to 3x minus 2, or y is equal to 3x minus 2. They all mean the same thing. In each case, the output is 3x minus 2 when the input is x. The notation f of 3 is used to represent the output number when the input number is 3. Thus, f of 3 is equal to 3 times 3 minus 2, which is equal to 7. So what we did was we swapped the x for a set of brackets and we put 3 into the brackets. For the function f of x 3x minus 2, if the input is 3, the output is 7. While f of x is generally used to describe a function, other letters such as g of x and h of x are used when dealing with more than one function. Example 1. F of x equals 4x plus 3 and g of x equals 3x squared are two functions. Find part 1, f of 3, part 2, g of minus 1, part 3, f of 2k, and part 4, g of k minus 3. So part 1, f of 3. So we're going to replace the x in f of x with a set of brackets and put 3 into the brackets. 4 times 3 is 12, plus 3 is 15. Part 2, g of minus 1. So we're going to swap the x in the g of x function with a set of brackets and put minus 1 into the brackets. So we've got 3 times minus 1 to be squared. Minus 1 squared is 1, and 3 times 1 is 3. Part 3, we're going to work out f of 2k. So we're going to go back to function f of x, which is our first one, 4x plus 3. We're going to swap that x for a set of brackets, and into the brackets we're going to put 2k. So we have 4 times 2k plus 3. 4 times 2 is 8, so we get 8k plus 3. And that's our answer. We just leave it like that. Part 4, we want to work out g of k minus 3. So we go to our function g of x, which was 3x squared. We replace that x with a set of brackets, and into the brackets we put k minus 3. So we have 3 times k minus 3 to be squared. So we're going to do our rough work first. So k minus 3 times k minus 3 gives us k times k minus 3 minus 3 times k minus 3, which is k squared minus 3k plus 9, which is k squared minus 6k plus 9. So then we have 3 times k squared minus 6k plus 9, which gives us 3k squared minus 18k plus 27. Some more examples. The functions f and g are defined on OR such that f of x maps to x plus 5 and g of x maps to x squared minus 1. So OR being the real number set, so all numbers on the number line. Find 1, f of 3, 2, g of minus 3, 3, f of 2k, 4, f of k plus 1, 5, g of 3k, and 6, g of k plus 1. So 1, f of 3. So we go to our function f of x, and we're going to swap that x for brackets, and into the brackets we're going to put 3. So 3 plus 5 is 8. Part 2, g of minus 3. So we go to our g of x function, we swap the x for brackets, and into the brackets we're going to put minus 3. Minus 3 squared is 9, and 9 minus 1 is 8. It's just a coincidence we've got the same output. Part 3, f of 2k. So we go to our function f of x, we swap the x for brackets, and into the brackets we put 2k. And 2k plus 5 is just 2k plus 5. We can't simplify that anymore. Part 4, f of k plus 1. So we go to our function f of x again, we swap the x for brackets, and into the brackets we put k plus 1. And k plus 1 plus 5 is k plus 6. We can't simplify any more than that. Part 5, a g of 3k. So we go to our g of x function, which is x squared minus 1. We swap the x for a set of brackets, and into the brackets we put 3k. And 3k squared is going to be 9k squared. So we've got 9k squared minus 1, and we can't simplify any more than that. And then part 6, g of k plus 1. So we go to g of x, which is x squared minus 1. We swap the x for brackets, and into the brackets we're going to put k plus 1. So we have k plus 1 to be squared minus 1. So we're going to do our rough work. K plus 1 to be squared is k plus 1 times k plus 1, which is k times k plus 1 times k plus 1, which is k squared plus k plus 1, which is k squared plus 2k plus 1. So k plus 1 to be squared gives us k squared plus 2k plus 1, and then we bring down the minus 1. And then the 1 and the minus 1 will cancel, so we're left with k squared plus 2k, which we can't simplify anymore, but we can factorize. So we can write k times k plus 2. So either of these answers will do. Composite functions. The diagram below shows a function f illustrated by the mapping diagram from a to b, and the function g illustrated by the mapping diagram from b to c. So here we have our set A, our set B, and our set C. So we can see 1 maps to 4, and that's following the function f, whatever that is. We don't know what our function is, f of x, but we know that 1 maps to 4. And then 4 maps to 11. So this is our g of x function. And again, we don't know what that is. So our f function and our g function are two different functions. Then 1 maps to 6, and then 6 maps to 15, and then 5 maps to 8, and then 8 maps to 19. So I've just followed the black arrows there. But what we could have done was jumped straight from 1 to 11. That's following the red arrow. And this would be known as g, and then it's like a little circle symbol. It's not a 0. It's how we pronounce this in maths is we say g after f. And likewise, the 3 could have jumped straight to 15. So this would be g after f. And then the 5 could have jumped straight to 19. And this again would have been g after f. So it's where the function g, so g is the second function. So g after f, so the function f was subbed into the function g, and then we got our outputs. The red arrow represents the couples of a new function combining f and g. It is called the composite function g after f. It is written as g circle f, how we pronounce g after f, or simply gf. The couples of gf from the diagram are 1, 11, so following the red arrows, 1 maps straight to 11, 3, 15, so following the red arrows, 3 maps straight to 15, or 5, 19. The 5 following the red arrow maps straight to 19. G after f is read g after f. We will now consider two functions, f of x equals 2x plus 5 and g of x equals x minus 3, to find the rule for the composite functions g after f of x. These functions are illustrated on the right. So we have our first set, then our second set, and then our third set. So we can see we start with x, and then we have our function f, which is 2x plus 5, and then the result of that is substituted into our function g, which will give us our output. So in f, the output is 2x plus 5 when the input is x. So the output is 2x plus 5 when the input is x. We will now use 2x plus 5 as the input for the function g. So 2x plus 5 will now be the input for the function g. So g after f of x is equal to g of 2x plus 5. Because remember, f of x is equal to 2x plus 5. So we have that up there. So that would be 2x plus 5 minus 3. So what we're doing is we're replacing the x in g of x with a set of brackets and putting 2x plus 5 into the brackets. And then simplifying, we get 2x plus 5 minus 3, which is 2x plus 2. What happens when the order is reversed? So if we did f after g of x, so that would be f of x minus 3, because g of x is equal to x minus 3. Well, then we would take the function 2x plus 5, we would replace that x with brackets, and we would put x minus 3 into the brackets. So we would have 2 times x minus 3 plus 5, which would give us 2x minus 1. Because 2 by x is 2x, and 2 by minus 3 is minus 6, and minus 6 plus 5 is minus 1. So f after g of x is 2x minus 1. So since 2x plus 2 is not equal to 2x minus 1, this shows that g after f of x is not equal to f after g of x. So if you reverse the order, you will not get the same answer. You might sometimes. It can happen that sometimes, but usually you will not get the same answer. If f and g are two functions, then f after g of x is not equal to g after f of x. Example 2. Given that f of x is equal to x plus 3 and g of x is equal to x squared minus 1, find f after g of 2, g after f of minus 1, f after g of x, and g after f of x. Find also the value of x for which f after g of x is equal to g after f of x. So f after g of 2. So f after g, i.e. work out g of 2, then sub that into f. So our rough work, so g of 2, so we're going to go to our g function, x squared minus 1. We're going to swap that x for brackets and put 2 into the brackets. So 2 squared is 4, minus 1 is 3. So g of 2 is 3. So g of 2 is 3. So now we need to work out f of 3. So we're going to go to our function f of x, which is x plus 3. We're going to swap that x for 3. So we have 3 plus 3, which is 6. So f after g of 2 gives us 6. Part 2. G after f of minus 1. So g after f, i.e. work out f of minus 1 and then sub it into g. So our rough work, f of minus 1. So we go to our function f of x, so x plus 3. We swap the x for brackets and we put minus 1 into the brackets. Minus 1 plus 3 is 2. So f of minus 1 is 2. So f of minus 1 is 2. So now we're going to work out g of 2. So we go to our g of x function, which is x squared minus 1. We swap the x for a set of brackets and we're going to put 2 into the brackets. So 2 squared is 4, minus 1 is 3. So g after f of minus 1 is 3. Part 3. F after g of x. So f after g, i.e. work out g of x, then sub it into f. So our rough work is g of x is equal to x squared minus 1. So there's nothing to actually do there. All we have to do, because we're not subbing in a number, so we're going to replace g of x with x squared minus 1. So if g of x is equal to x squared minus 1, then we replace g of x with x squared minus 1. So now we need to work out f of x squared minus 1. So we go to our function f of x, which is x plus 3, and we're going to replace that x with a set of brackets and put x squared minus 1 into the brackets. So we have x squared minus 1 plus 3, which simplifies to x squared plus 2. So f after g of x is x squared plus 2. Part 4. G after f of x. So g after f, i.e. work out f of x, then sub it into g. So f of x is equal to x plus 3. So there's no real rough work to do here. So we're going to replace f of x with x plus 3 because f of x is equal to x plus 3. So then we're going to work out g of x plus 3. So we get our function g of x, which is x squared minus 1, And we're going to replace the x with a set of brackets and put x plus 3 into the brackets. So we have x plus 3 to be squared minus 1. Now we have to do a bit of rough work here. X plus 3 times x plus 3. So here's our rough work. X plus 3 times x plus 3 is x times x plus 3 plus 3 times x plus 3, which is x squared plus 3x plus 3x plus 9, which is x squared plus 6x plus 9. So x plus 3 times x plus 3 is x squared plus 6x plus 9, and we bring down the minus 1. And then we just simplify to get x squared plus 6x plus 8. So here we have a quadratic trinomial. So g after f of x is x squared plus 6x plus 8. Find also the value of x for which f after g of x is equal to g after f of x. So f after g of x is equal to x squared plus 2. So we work that out in part 3. And g after f of x is equal to x squared plus 6x plus 8. We work that out in part 4. So we're going to let them equal to each other. So we have x squared plus 2 is equal to x squared plus 6x plus 8. And then we're going to solve for x. So we're going to do letters to the left, numbers to the right. So we've x squared minus 6x is equal to 8 minus 2. So our x squareds will cancel. And then we have minus 6x is equal to 8 minus 2, which is 6. And then dividing both sides by minus 6, we get x is equal to minus 1. So we were asked to find also the value of x for which f after g of x is equal to g after f of x. And we got minus 1 for our x value. Example 3. F of x maps to 4x and g of x maps to x plus 1. Define two functions. If g of 3 plus k of f of 3 is equal to 8, find the value of k. So we're going to do our rough work. So we're going to work out g of 3 first. So that's our first bit there. So our g of x function is x plus 1. So we're going to swap the x for brackets and put 3 into the brackets. And 3 plus 1 is 4. So g of 3 is 4. Then we're going to work out f of 3. So f of 3, we're going to go to our function f of x, which is 4x. We're going to swap that x for a set of brackets and put 3 into the brackets. 4 times 3 is 12. So f of 3 is 12. So we have g of 3 plus k times f of 3 is equal to 8. So g of 3 is 4. We got that from our rough work over here. Plus k times f of 3, which is 12, is equal to 8. So then we're just going to simplify and solve. So multiplying out our brackets. So k times 12 is 12k. A number times a letter, we stick them together. And then solving for k, bringing letters to the left, numbers to the right. We get 12k equals 8 minus 4. So 12k is equal to 4, and dividing both sides by 12, we get k is equal to a third. So we are asked to find the value of k. K is equal to a third.